Hey everybody, this is the addition rule in statistics in our elementary statistics class. This is section 3.3, so let's go ahead and get started. So two events, A and B, are mutually exclusive when A and B cannot occur at the same time. So something like this, where there's no overlapping of the two. Okay, so if there is overlapping, then they're not mutually exclusive right here. So say like A was all numbers less than 20, and then B was all odd numbers, and then so there'd be some overlap inside of there, okay, something like that, so they wouldn't be mutually exclusive. So determine whether the events are mutually exclusive and explain. So event A is rolling a 3 on a die, and event B is rolling a 4 on a die. Well, these two outcomes cannot occur at the same time, so the events are mutually exclusive, all right? So how about randomly selecting a male student? Event B is randomly selecting a nursing student. Well, these guys are, because a male student can be a nursing student, they are not mutually exclusive, okay? So here's the addition rule for probability. So the probability of event A or B, notice the word or, that's the important keyword there, is this, you guys. The probability of A or B is the probability of A plus the probability of B minus the probability of their overlapping, whether they're mutually exclusive or not. So if the events are mutually exclusive, then it just is the probability of A plus the probability of B. And the reason why is, if we took this and we concluded the probability of A and we did plus the probability of B, this middle part gets included twice from this guy and this guy. So that's why we subtracted out once to find the probability of A or B. Okay, so this is called the addition rule for probability of A or B. All right, so use the addition rule to find the probability. So you select a card from a standard deck of 52 cards. Find the probability that the card is a 4 or an ace, okay? So you can't get a 4 and an ace, so these are mutually exclusive, so it's just the probability of a 4 plus the probability of an ace, okay? Well, there's 4 cards out of 52 cards of 4s, and same with the aces, so you get that, you can reduce that, and so there's our answer you'd find in the back of the book. They usually put it out to 3 decimal places to the thousandths spot. Remember, tenths, hundredths, thousandths place value. So this reads 154 thousandths, okay? All right, so here we roll a die, find the probability of rolling a number less than 3 or rolling an odd number. Okay, so they are not mutually exclusive, so you find the probability that it's less than 3. So a 1 or 2. There's two chances out of 6. The probability that it's odd, okay, so there's 3 chances out of 6, and then minus the probability that one number that's less than 3 and odd, okay, so we get those right there, and so that reduces, and of course that's 667 thousandths THS, okay. All right, so here are the number of donors who gave each blood type. There should be a period right there. I think I have that. So if in the next slide, so there should be a period right there. I'll insert that right here. All right, for each blood type. Okay, so a donor is selected at random. Find each probability, okay? So the donor has type O or type A blood, okay? Well, they can't have type O and type A, so they're mutually exclusive, okay? So the probability that's type O is this divided by total. The probability that's A is this divided by the total right there. So we're going to get that, and it gives us 851 thousandths, okay? How about this? The donor has type B or is Rh negative, okay? So here's type, right here, here's type B right here, 45 out of this right here. And then here's Rh negative, 65 out of this right here. And then we got to subtract off the overlapping part right there, okay? So we get that, and that gives us that, which is about 249 thousandths, okay? All right, so if you are in my class, that would have been your assignment for this lesson. Take care.